Picture this. Your team splits the infrastructure in two. App servers in one VNet. Database in another. Clean separation. Good security hygiene.
Then deployment day comes.
The app cannot reach the database. Ping fails. Connections time out. Everything is broken. Here is the thing nobody warns you about. Azure VNets are completely isolated by default. Two VNets in the same region, same subscription, they cannot see each other. That isolation is intentional. It is a security feature. But real applications do not live in one network. Production and dev are separated. Databases are in their own VNet. Acquired companies bring their own networks. Teams expand across regions. You need those networks to talk safely and fast. That is exactly what this video solves. Two tools, VNet Peering and VPN Gateway. By the end you will know exactly which one to use and when. VNet Peering is the simplest and fastest way to connect two Azure networks. You create the peering link. Within seconds, VMs in both VNets can communicate directly. No public internet. No VPN. No encryption overhead. The traffic travels across Microsoft's private backbone, the same cable infrastructure that connects Azure data centers. The latency is essentially the same as being in one VNet. But here's the catch. Peering is not automatic in both directions. You create A to B. You must also create B to A. If you only create one direction, traffic flows one way and breaks in the other. I have seen this exact mistake in production. One more thing people miss. Peering is non-transitive. VNet A peers with VNet B, a VNet B peers with VNet C. VNet A cannot reach VNet C. Peering does not chain. Keep that in mind as your network grows. Global peering works the same way, just across regions. Your VNet in East US peers with your VNet in Southeast Asia. Traffic still stays on Microsoft's backbone. No public internet. Low latency. Simple setup. Now this is where most people get tripped up. IP address overlap. If VNet A uses the range 10.0.0.0.0/16 and VNet B also uses 10.0.0.0.0/16, you cannot peer them. Azure does not know which 10.0.1.5 you mean. This is why IP planning matters before you create your first VNet. Once IPs overlap, fixing it requires rebuilding. There is no easy patch. Plan your CIDR blocks on day one. Give each VNet a unique range. Future you will be grateful.
Also, cross-region peering has a small per GB data transfer charge.
Within the same region it is free. Keep that in your cost model. Since peering is non-transitive, enterprises solve this with hub-and-spoke architecture. One central VNet, the hub.
Everything shared lives here, your firewall, your DNS servers, your monitoring tools.
All your application VNets, the spokes. Each spoke peers only with the hub. Here is the powerful part. When spoke A needs to reach spoke B, the traffic goes through the hub. The firewall in the hub inspects it. Policies apply. Logging happens. You get central visibility over all inter-network traffic. This is the pattern Microsoft recommends for enterprise Azure deployments. One hub per region. Dozens of spokes.
New teams get a new spoke VNet, peer to the hub.
They inherit all the shared services instantly.
And here's what makes it really clean.
If you need to update your firewall rules, you do it once in the hub. Every spoke gets the new policy automatically. Central control. No duplication. VNet peering connects Azure networks to each other. But what about your physical office? Your on-premises servers? Your data center? Your developers at home? They cannot peer, they are not in Azure. That is where VPN Gateway comes in. A VPN gateway creates an encrypted tunnel between your Azure VNet and your on-premises network. Traffic travels over the public internet but inside an IPsec encrypted tunnel. Nobody in the middle can read it. Site-to-site VPN is the permanent version. Your office router connects to the Azure VPN Gateway.
Every machine in your office can reach Azure resources as if they were on the same local network.
Developers can hit internal Azure services. Azure services can reach on-prem databases. This is the standard pattern during cloud migration.
You run hybrid for months or years.
Some workloads in Azure. Some still on-prem. Site-to-site VPN keeps them talking throughout. Here is a scenario every team faces. Developer works from home.
They need to access an internal API that lives in a private Azure VNet. No public IP on that API by design for security.
Without point-to-site VPN, they cannot reach it. Point-to-site VPN puts a VPN client on the developer's laptop. They connect. Azure authenticates them. Now their laptop is virtually inside your Azure VNet. They hit the internal API like they are sitting in the office.
And here is the mistake many teams make. They expose internal services with public IPs just to let developers access them.
That is a massive security risk. The right answer is point-to-site VPN. Keep the service private. Give developers a secure tunnel. Setup is straightforward. Download the VPN client config from Azure. Install on the laptop. Connect. Done.
Authentication can use certificates, Azure Active Directory, or your existing Radius server.
Teams with Azure AD can make it completely seamless single sign-on into the VPN. This is where most people get surprised by the bill. VPN Gateway is not free. It runs 24 hours a day, 7 days a week, billing by the hour regardless of traffic. Even if nobody is connected, it is running.
So choosing the right SKU matters for cost.
Basic SKU, do not use it in production. It has no SLA and is being deprecated. For small teams, VPN GW1 gives you 650 megabits per second and up to 30 site-to-site tunnels. For larger organizations, VPN GW3 doubles the throughput. For enterprise scale, VPN GW5 supports up to 10 gigabits and 10,000 connections.
Now pay attention here, this one matters for production.
Always use active-active mode.
2 gateway instances running simultaneously. If one fails, traffic automatically shifts to the other.
Without active-active, a gateway failure means your entire office loses Azure connectivity. That is a very bad day. VPN Gateway is great.
But it has a ceiling.
Your traffic still travels over the public internet. Even encrypted, you share the internet with everyone else. Latency varies. Bandwidth fluctuates. During peak hours, performance drops. For most companies, VPN is fine. But for banks, hospitals, and large enterprises, variable latency is not acceptable. That is ExpressRoute. A dedicated physical connection from your data center to Microsoft's network. Provisioned through a network provider, Tata, Airtel, AT&T, whoever your provider is. Your traffic never touches the public internet. The performance difference is dramatic. Consistent sub-10 millisecond latency. Guaranteed bandwidth. No congestion. No sharing. The cost is dramatically higher too. Circuit costs plus Azure Gateway costs. But for regulated industries or massive data movement workloads, it pays for itself. The decision is simple.
If you need guaranteed performance or compliance mandates private connectivity, ExpressRoute.
If you need connectivity at reasonable cost, VPN Gateway. Let me make this simple. If you are connecting two Azure VNets, always use peering first. Lowest latency. No gateway needed. No hourly cost within the same region. Simple to set up. Done in minutes.
If you are connecting Azure to your physical office or data center, VPN Gateway.
Encrypted tunnel. Works over existing internet connection. Site to site for the whole office. Point to site for individual developers. If you need guaranteed performance and compliance, ExpressRoute. Private circuit. Premium cost. Worth it for the right workloads. Here is the real-world pattern I see most. Peering everywhere inside Azure using hub and spoke. VPN Gateway for the office and remote developers.
ExpressRoute for the core data center once migration is complete and volumes justify the cost.
3 tools. 3 different jobs.
Now you know exactly which one belongs where.
That is VNet Peering and VPN Gateway. This is part 20 of the Azure series.
If you are serious about becoming a cloud engineer, subscribe and keep going.
Next up, Azure Key Vault and why you should never hardcode a password again.